Two corporate databases, the Red Corporation and the Blue Corporation. We wish to keep these two databases irrefutably aligned. We do this by multiplexing all write operations to the databases. Any write operation is first validated, an invalid request will be bounced. To support replication, several extra tables exist on each database. Upon insertion to the record, the hash digest of the entire record is calculated incrementally, and the details of the operation and the resultant hash are written to the database. The web server then returns the success value, and the request response promptly returned to the originating client. An independent transmitter daemon now transmits the request and the hash values to all parties. A receiving daemon accepts this and checks that the transmitter at least has permission to edit the record. Further tests are then taken to ensure the precise operation is valid before updating the record and transmitting WebSockets updates notices to any listening clients. As with the originating operation, the resultant hash is calculated and stored in the extended tables. The hash is then returned, usually in direct response to the originating request, or if there has been a timeout, via the remote transmitter's daemon. The result is a trusted intercorporate database. Employing this principle and the joys of object relational mapping technology, we have developed a feature-rich document or contract model. The core of this is something I call the Generic Elemental Model, or GEM. Work on the GEM is ongoing. The framework it employs is intended for use by professional engineers to support patterns and functionality previously unsupported, but it's a bit too complicated to talk about now. So let's just make a contract with our GEM. A top-level block is by default termed contract. Subblocks can be added and fields added to them. The tree can be of arbitrary depth. This block will be a special block used to generate an array. A prototype web UI exists to generate and manage all of this. Structure and rules can be mutually agreed between parties. The record structure and rules can then be locked and set to a state where values can be submitted to the leaf gems, subject to compliance with any access rules or value constraints which may have been set. This constitutes an intercorporate application. Assignment rules can be set. These are executed upon completion of all inputs. The stack is fully reactive and any remote clients will see live updates to pages. Blocks can be defined as array templates which are replicated upon request for a new subrecord. Contention is avoided by segregating the record on ownership. Ownership can be requested by a remote party, and subject to validation, the remote automatically submits ownership. The blocks can be of arbitrary size. A Merkle tree is used to manage the hash of these arrays. Incremental aggregate functions exist, such as sum and average. The reactive system can be directed to alert or drive other services and data systems, even value transfer. This constitutes intercorporate information technology. Engineers have a non-blocking database interface that allows them, subject to agreed rules, to write into a remote corporation's database. It is underpinned by irrefutable cryptography and a transparent and simple rules system. There is the potential for technically able end users to manage and even commission systems. With a market framework, we have the potential for the network to drive standardization. Contracts can be shared, further developed and modularized.